According to the National Electrical Code, specifically Article 250.50a on, all grounding electrodes that are part of the grounding system must be bonded together to form the grounding electrode system. This requirement applies even when multiple services are present on the same premises, regardless of the distance between them. In the described scenario, where there are two 2000 amp services located 300 feet apart within a building lacking metal water piping or effective grounded structural steel, connecting the two services with a properly sized grounding electrode conductor is necessary. The primary reason for this requirement is to establish a common ground reference point for both services. This common reference point ensures that any fault currents can effectively flow back to the source, facilitating the operation of overcurrent protection devices such as circuit breakers or fuses. Without this connection, the impedance of the earth path may be too high, hindering the clearing of faults and potentially creating dangerous voltage potentials. To determine the appropriate size of the bonding conductor, refer to Table 250.66 of the NEC. This table provides guidance based on the size of the largest service conductor. In the case of a 2000 amp service, a minimum of 3/0 American wire gauge copper conductor is required. It is crucial to consult the specific table and conductor material to ensure compliance with the NEC. The installation of the bonding conductor must adhere to the requirements outlined in NEC Article 250.64. The conductor should be run as directly as possible between the two service locations, minimizing bends and unnecessary length. Additionally, the conductor must be securely fastened to the building structure at intervals not exceeding 6 feet. This securement prevents the conductor from becoming damaged or displaced, ensuring its continued effectiveness. Although the NEC does not mandate a specific maximum grounding resistance value for the combined grounding electrode system, it is generally advisable to strive for a resistance of 5 ohms or less, particularly for lightning protection purposes. Achieving a low grounding resistance can be accomplished through proper spacing and depth of the ground rods. The arrangement of ground rods should be optimized to minimize overlap of their effective zones. Increasing the depth of the ground rods can also contribute to lower resistance by reaching lower soil layers with more stable moisture content. The absence of metal water piping or effective grounded structural steel in the building emphasizes the importance of the ground rod system. These elements, when present, typically contribute to the overall grounding effectiveness. Therefore, in their absence, careful attention must be paid to the installation and performance of the ground rods. In summary, connecting the two services with a properly sized grounding electrode conductor is essential for safety, effective fault current management, and overall electrical system performance. Compliance with NEC Articles 250.50a on, 250.66, and 250.64 is crucial. Proper sizing of the conductor, secure installation, and attention to grounding resistance will contribute to a safe and reliable electrical system. Firstly, the grounding electrode conductor serves to equalize the ground potential between the two service locations. Without a common grounding electrode conductor, there could be a difference in potential between the two ground systems. This potential difference could create a shock hazard if a person were to come into contact with grounded equipment connected to different services simultaneously. Secondly, the grounding electrode conductor provides a low impedance path for fault current to flow back to the source. This low impedance path is essential for the rapid operation of overcurrent protective devices, such as circuit breakers and fuses. When a fault occurs, a large current flows through the grounding system. If the grounding system has high impedance, the fault current may not be large enough to trip the overcurrent protective device. This could result in a prolonged fault condition, which could damage equipment or cause a fire. Thirdly, the grounding electrode conductor helps to protect against lightning strikes. Lightning strikes can cause severe damage to electrical equipment and can even start fires. A properly installed grounding electrode system can help to dissipate the energy from a lightning strike into the earth, protecting the electrical system and the building from damage. Fourthly, the grounding electrode conductor helps to reduce electromagnetic interference. Electromagnetic interference can disrupt the operation of sensitive electronic equipment. A properly installed grounding electrode system can help to shield the equipment from electromagnetic interference. Fifthly, the grounding electrode conductor is required by the NEC. The NEC is a set of standards for electrical installations that are designed to protect people and property from electrical hazards. Compliance with the NEC is mandatory in most jurisdictions. In the specific case of a 2000 amp service, the size of the grounding electrode conductor is determined by Table 250.66 of the NEC. According to this table, for a 2000 amp service, the grounding electrode conductor must be at least 3/0 American wire gauge copper or 250 kc mil aluminum. The grounding electrode conductor must be connected to the grounding electrodes at each service location. The grounding electrodes can be ground rods, ground plates, or other approved grounding electrodes. The grounding electrode conductor must be installed in a neat and workmanlike manner. It must be protected from physical damage and must be securely fastened to the building structure. The grounding electrode conductor must be continuous and without splices. If a splice is necessary, it must be made with an approved splicing method. The grounding electrode conductor must be accessible for inspection and testing. It must not be concealed behind walls or ceilings. The grounding electrode conductor must be identified with a green color or with a tag that indicates that it is a grounding conductor. The grounding electrode conductor must be tested to ensure that it has a low impedance path to ground. The test can be performed with a ground resistance meter. The grounding electrode conductor must be inspected regularly to ensure that it is in good condition and that it is properly connected. If the grounding electrode conductor is damaged or corroded, it must be replaced. In addition to the grounding electrode conductor, the equipment grounding conductors must also be properly sized and installed. The equipment grounding conductors are the conductors that connect the non-current carrying metal parts of electrical equipment to the grounding system. The equipment grounding conductors provide a low impedance path for fault current to flow back to the source, protecting people and equipment from electrical shock. The size of the equipment grounding conductors is determined by Table 250.122 of the NEC. According to this table, the size of the equipment grounding conductor must be based on the size of the overcurrent protective device that protects the circuit. The equipment grounding conductors must be installed in the same raceway or cable as the circuit conductors. This ensures that the equipment grounding conductors have a low impedance path to ground. The equipment grounding conductors must be securely connected to the non-current carrying metal parts of electrical equipment. The connections must be made with approved connectors. The equipment grounding conductors must be continuous and without splices. If a splice is necessary, it must be made with an approved splicing method. The equipment grounding conductors must be accessible for inspection and testing. They must not be concealed behind walls or ceilings. The equipment grounding conductors must be identified with a green color or with a tag that indicates that they are grounding conductors. The equipment grounding conductors must be tested to ensure that they have a low impedance path to ground. The test can be performed with a ground resistance meter. The equipment grounding conductors must be inspected regularly to ensure that they are in good condition and that they are properly connected. If the equipment grounding conductors are damaged or corroded, they must be replaced. In conclusion, connecting the two services with a properly sized grounding electrode conductor is essential for safety and proper operation of the electrical system. This will ensure that there is a continuous path for fault current and lightning surges, providing protection to equipment, personnel, and the building itself. Remember to always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Proper grounding and bonding practices are crucial for safe and reliable electrical installation.